Hey everyone, Mr. Scullin here, back at it, Lesson 3, Unit 6. We're in our probability unit, and you can see I started to write down a couple things already. We're talking about conditional probability today. That's our focus for Unit 3 is conditional probability. On the right-hand side, I started to write down some of the concepts that we've covered already that we've been able to calculate some probability. One is independent events, and that's where, if like we're flipping a coin, if we flip the coin twice, the first flip does not affect the second flip. We consider those independent events. Dependent is when the first event does affect the second event, okay? So it does affect the second event, and that's something like if you had a bag of marbles and you pull out one marble and you do not replace, then that total has been changed by 1, and so that first pull with you not replacing does affect. Mutually exclusive, that's when we had the or, right? When we have two things that can't happen at once. And then the non-mutually exclusive, where we have to subtract the overlap. And we did that in Unit 2, or Lesson 2. We have to subtract the overlap of the two situations. So that's just a quick review of what we've done so far. Conditional probability, you're going to see a lot of similarities between conditional probability and dependent events, where one thing happens and it affects the rest. Okay, and so you're going to see a lot of similarities between that. So let's just jump right into it right here. So here's our definition. What is conditional probability? Conditional probability is the probability of an event A taking place given that event B has already occurred. Okay? This is the notation. So really conditional probability, like I said before, is like a dependent situation, dependent events. We just use notation. This is a notation. And all that notation does is allows us to use algebra, right? And everybody likes algebra because you can just plug things in and go. So we have a nice little formula here for you. Now let's break down the formula. You would interpret this or read this as the probability of A. This straight line right here means given that. So we would write this or read this as the probability of A given that B has occurred. Okay? That's how we would read that. Here is the nuts and bolts of the formula. This part right here is the intersection of A and B. Okay? So the probability of A and B taking place over the probability of B. That's the fraction that we're going to set up. So you'll see that take place here in a couple of the examples that we do. All right. So the first example is one we've kind of seen before in some of the homework problems. And so let's take a look at it. We're going to create a Venn diagram. All right, so what's the situation? We have 100 students. 40 are taking algebra. So I'm going to put an A for algebra, and I'm just going to write a 40 off to the side. Okay, that's the total. And 30 are taking biology. 20 are taking both. So there's my second circle. There's B for biology, and we know there are 30 total. We know that there are 20 taking both. So here's how you fill in that Venn diagram. Remember, if 20 are taking both, that 20 that are taking both is incorporated into the total number of 40. So really, there's only 20 students who are just purely taking algebra. Likewise, there's only 10 students who are purely taking biology, right? Because the 20 plus the 10 makes 30, and the 20 plus the 20 makes 40. So that's how we would fill in our Venn diagram. So let's read the question starting here. If a student chosen at random is already taking algebra, what is the probability that he or she is taking biology? Well, let's put that into the notation. The probability, what's the probability that they're taking biology given that they're already taking algebra? That would be our setup. So it would look something like this if we were to write out the formula. The probability of the intersection of biology and algebra over the probability that they're already taking algebra. So all we need to do now is just fill in the numbers, right? So usually this bottom one is the easiest. So the probability of a student taking algebra, well, we know that total is 40. What's the probability or the intersection of students who take biology and algebra? The intersection or the combination would be 20. So it's 20 over 40, and we get 1/2. So the answer to this question, the probability that he or she is taking biology given that they're taking algebra, would be 1/2. And that would be our answer. You can make it a percentage, easily 50%. Okay? Now, there are a couple situations, and I have two of them here. They're a little different. where you don't have to use the formula. I know it says using the formula, but you don't have to. In fact, I'm going to use something slightly different just to give you some variety. You can use the formula here, but again, I think sometimes the formula, sometimes Venn diagrams can almost inhibit just some basic number sense and some basic knowledge. And so don't feel like you have to use the formula or use a Venn diagram every time. You can kind of just use some common sense sometimes and some number sense. So let's take a look. What's the probability of a couple having 2 girls if we know that at least one of the children is a girl? All right, well, there's a situation where here are your options, right? They could have boy, boy. So the first child's a boy, second child's a boy. They could have a boy, girl, a boy first, a girl second. They could have girl, girl, 2 girls, and they could have girl, boy. That's really our 4 choices. I'm going to make like almost like a little Punnett square from your biology days, right? So what is the probability of a couple having 2 girls? Which one of these boxes is already out of the question, given that at least one has to be a girl? Well, that one's out of the picture because there's 2 boys. So what are our total amount of outcomes? Our total amount of outcomes, there's only 3, okay? And what is the probability that the couple has 2 girls? What's the only box that has the 2 girls? It's that one. So it's just 1/3. And you can see this is a PowerPoint, so I left the answer on there for you, but 1/3 is our answer. So there's a situation where you don't have to use a formula. You don't have to use a Venn diagram. You can just use some different ways to figure that problem out. All right, let's come over here. Same kind of problem. I know the answer is there. See if you can get it on your own without looking at the answer. So this one says, what's the probability of a couple having 2 girls if we know that the oldest, boy, 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 girl, first boy is written first, so we're assuming that's the oldest, second girl, 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 boy. All right. So again, what's the probability of a couple having 2 girls? That's out of the picture. All right. If we know that the oldest is a girl, well, what situation is the oldest in the boxes remaining where the oldest is a girl? Right there. Okay. So this one is out of the picture as well because the conditional has to be that the oldest is a girl, that oldest is a boy, so that one can't count. So we have 2 boxes left, and which one has 2 girls? That one there. So there's your 1/2. Okay. This is a question that you're going to see, you can see often, and this is a good problem. They're frequency tables. So we did frequency tables in lesson 1. I told you we would kind of come back to these, and here's a perfect example when we use frequency tables to represent conditional probability. So first thing is we want to fill in the missing numbers. I'll save you a little bit of time. We'll go through this quickly for you. This is 12. So basically you have 16 plus 12 equals 28 because that's the total. You have 46 plus 51 equals 97. The total has to be 6, so you have 3. This has to be 3. And then you have totals also going from left to right, right? 16, 46, and 3 make 65. 12, 51, and 3 make 66. And 28, 97, and 6 make 131. I hope those numbers are correct. So once we've filled in the table, now we're going to answer questions B and C. So if you take a look at this, again, it says find the probability that a person chosen in this population has a bachelor's degree given that they're a male. So these are nice to actually use the formula because basically what you have is the probability that they have a bachelor's degree intersecting with a male over the probability that they're a male. Okay? So if we take a look at, I always like to kind of work backwards or from the bottom up. You can almost look at it this way, right? This line, it means given that, but it also, for me, can mean like the bottom of the fraction. So the bottom of the fraction is going to be the number of males. Let me flip it back around here. So the number of males we have is 65. So there's 65 total males. Now, what's the intersection of the males that have bachelor's degrees? Males that have bachelor's degrees, 46. So 46 over 65 would be our answer for B. If you want to make it a percentage, take your calculator, 46 divided by 65, and you get about 70%, okay, 70.7%. Part C says, find the probability that you have a female given that the female has a master's degree. So, again, we would do something like this. The probability that it's a female intersecting with a master's degree over the probability that the female has a master's degree. So again, I work from the bottom up. Again, this is the bottom number, master's degree, the total. The total master's degree would be 6, right there, master's degree, 6 total. And then the combination of females with master's degree is 3, so we have 1/2 or 50%, okay? So that's an example of using some frequency tables that we touched on in the first lesson, and now we're using those frequency tables to calculate some conditional probability. And I think that's all she wrote. So there's lesson 3, conditional probability. If you have any questions, be happy to clear those up. Again, you'll see a variety of questions on your assignment, and let me know if you have questions. Look forward to seeing you in class. Take care.